So, good afternoon, everyone. Welcome to lecture 13 of cloud computing. So, in this lecture, we'll focus on three different cloud service provider. First one is your Amazon Web Service, right? Second one is your Google App Engine, GAE. Third one is called as the Microsoft Azure, or earlier it is called as Windows Azure. So, these three platforms provides various cloud services as well as location based cloud. So we are going to discuss about these three cloud in detail, especially in terms of their architecture, what kind of security features they have, what kind of services are offered by these cloud service provider, that we will discuss in today's class. So as you know that in cloud computing, the main support we are getting through the virtualization technology, right? So all the cloud service providers are using virtualization technology in order to provide various services to the customer, right? So this virtualization technology also help for disaster recovery. If some that I tell you in the it's how to make this disaster recovery, but this virtualization also supports disaster recovery in case of that in case of any failure. So you can retrieve the things. For example, a virtual machine is crashed. The same thing can be retrieved by applying the recovery policy. So AWS, if you see, AWS provide extreme flexibility. So you can visit to EC2 website, Amazon EC2 instance. Okay, you can create your account, or you can go for Amazon S3. You will see the virtual machines you can create based upon the template already given in these particular websites. For example, like I told you about T2 micro instance, T2 mini instance, right? So it provides more flexibility to the user. Okay, so before you are deploying any applications, whatever requirement you have, that requirement you can get, right? You have to match your requirement with whatever provided by Amazon EC2. Okay, you can subscribe the instances from the Amazon EC2, right? So you will get more flexibility as a user, but such facility is not applicable in all the cloud service providers. Okay, like I told you one word that is called as customization. Customization facility is not not provided by all the cloud service providers. Sometimes their policies are already defined, you have to choose one of the policy, right? Or sometimes or you can say some cloud service provider provides the features of flexibility or customization, so that as per your requirement you can deploy your application. But many cloud service providers are there, customization is not there, right? Coming to the GAE, if you go for Google App Engine, Google App Engine has limited application level virtualization for user. And if you see whatever APIs and whatever flexibility in comparison, if you compare with Amazon Web Service with Google App Engine, you will see Google App Engine is not that much flexible. Okay, and it provides the services that are created by Google. Various apps are provided by Google, like Google Map is there. Okay, Google Drive is there, right? Google Assistant is there. So they are these services are provided by Google only, right? So if you need such services, you have to rely on Google. You cannot go for your own flexibility as provided by Amazon Web Service. That's why if customization is required, many people are using AWS instead of your Google App Engine, right? So you have to see what kind of requirement you have. Based upon that, you have to go through the characteristics of each and every cloud, and you have to subscribe a particular cloud. Similarly, if you go for Microsoft, Microsoft uses the .NET framework and provides the programming level virtualization for the user. Okay, that's why I told you, in order to subscribe the cloud, first you have to go for their features. Before signing the service level agreement, you have to decide which cloud is more appropriate for you based on your requirement. And also this is an important factor, that is the power consumption. We repeatedly discussed this power consumption part, and the analysis also says that 3% of the total energy consumed in the US is due to the IT. IT infrastructure. IT infrastructure is consuming 3%, and drastically it is increasing because the number of devices per person is also increasing. Okay, we are using smartphone, we are using smart TV, right? Many things are we are using, like laptops. Nowadays people are using 2 3 laptops due to this COVID situation, right? So if you see such case, the power consumption is increased, so we have to reduce it. How you can reduce? If you convert, or if you move from your traditional IT to your cloud computing. Okay, like if you go for IDC report or the Gartner survey, you will find virtualization will help you to reduce the power consumption, because you are using the same physical machine, and the same physical machine is shared by multiple people. So if you see the traditional IT, where there is a dedicated system for user, by applying the virtualization technology, what will happen? The virtualization technology will enable you to create multiple VMs over a single physical machine. So obviously the number of physical machines required is less, right? So you will get the cost reduction. If the power is reduced, then ultimately your energy cost is saved, or yeah, the way you are expanding your data center is also not that much required. Right? That is the advantages you will get if you go for virtualization in the green data center. Nowadays, everyone thinks about this word, that is green. Right? Green indicates that you have to ensure that it should be energy efficient. Energy is utilized properly. Okay. So I will give you a very small illustration so that it is more clear. For example, you have two servers. One is server one, another is, let's say, server two. Right? And assume that both servers are identical in nature. By the term identical, just I want to tell whatever the resources H1 has, H2 has the same resources. Just like I purchased same computer twice, okay, or two different computer having the same configuration, right? Everything is same. Their configuration, characteristics, features, everything is same. For example, one customer deployed a particular application in the server one, right, which consumes 40% of 40%, which results 40% utilization of the server one. Okay, another customer deploy another application in the server two, and it leads 30%. Okay, it takes 30%. The resultant is 30% of the resource utilization. So you have two solutions. One solution is you will switch on the server S1, okay, which will take the load of 40% as well as plus 30%. That is for the first customer and 30% for the next customer, right? And you will make the server 2 switch off. Server 2 is not required, right? As some of the utilization is not exceeding 100%, both user 1 and user 2 work can be completed by a single server, right? That is another solution. One solution. Another solution, you have to go like this only, right? Server 1 is also active, server 2 is also active, right? So just tell me which solution is better. Solution 1 is better or solution 2 is better? Because the first case I need only one server, second case I need server 1, server 2, as I told you in the previous case, right? Just in the traditional IT, we have two servers. One server is 40% utilization, another server with 30% utilization. Okay, but one of the solution may be you may combine the load. You can consolidate the load of server 2 to server 1 and put server 2 in the switcher mode or sleep mode or some mode where you can save power, right? So can anybody tell which solution is better? Solution 1 is better or solution 2 is better? Please write in the chat box. Let me see the chat box. Which solution is better? Please write in the chat box. Which solution is better? Solution 1 or solution 2? Please respond in the chat box. Solution 2 is better. Okay. Any other person whose solution is better? Which solution is better? Can anybody write in the chat box? 2 only. Okay. Another person is also 2. Any other respond? Please respond. Solution 1 is better. Why 1 is better? Why 2 is better? Can anybody explain? Please unmute and tell why you think solution 1 is better or 2 is better.
Solution one is better because we are not using the second server because it's not of any use at all because the first server itself is at 70% usage.
Yes, on that basis, the first solution is better. Why solution 2 is better? Solution 2 is better. Why? You are using 2 server. Why you think solution 2 is better? To tell, based upon your viewpoint, why you are thinking solution 2 is better. Then I will tell you what is the solution. Scaling is there. So why scaling? If one server is close to 100%, then they go for the second server. That is called as a scaling. Scaling means you can say in order to make a suppose a particular server is overloaded, then you can go for scaling the server to another one, means 1 to 2. Then the load can be shared. In that manner, scaling will work. But in this case, it is only 40%. Any other reason in favor of the solution number 2? Better resource utilization. No, resource utilization is poor, right? Resource utilization, if you go for solution number 2, then you know that one is busy for 40%, another is busy for 30%. Both resource utilization is less only, right? Both case the resource utilization is less only. But if you go for solution 1, the resource utilization is 70%, right? So obviously 70% is more than 40% or 30%. So solution 1 is better than the solution 2. Is there any other parameter? Anybody? Any parameter? Any other thing? Okay, in this case, if you see, yes, anybody want to tell anything? Okay. In this case, if you see, both solution is better, right? I'm not saying solution 1 is not better or solution 2 is not better. It purely depends upon what kind of energy, okay, how much energy is consumed in the solution 1 and solution 2, right? Like solution 1 is mentioned that first server is busy for 70% unit of time and second use is not used, right? This is the first scenario. Second scenario, first server is busy for 40% of time, second is busy for the 30% of time, right? First is busy for 40, second is busy for 30% of time. Okay. So if you see the resource utilization, one person told about the resource utilization perspective, the solution one is better. Okay. Another person point about the scaling. So here there is no concept of scaling because 40% or 30% is not a overutilization. If it is a overutilization, means close to 100%, then you need another server. But the thing is that you have to see what kind of energy model used for this particular solution. Like one case, one person can say energy utilization, if you calculate, if you take utilization, let me take utilization here in the x-axis, and let me take power or energy consumption in the y-axis. So just I want to see if the utilization is increased, then whether the power is increased in the same rate or power is increased in different rate. If that is linear one, means 10% whatever energy, 20% is just double of that. Then if it is like that, then you can say 70% is better, a solution is better, right? Or you can at the same time you can also claim that if I have two server, why to make one server idle, right? I'm not using that server, I can use the two server, but first server is busy because the same energy is consumed by 40 and 30%, and same energy is consumed by the 70% server. Both are performing same, right? Only advantages you will get in solution one is one system is switch off, okay? So maintenance is not required. In that manner, you can say first solution is better. But what happens if this curve is a exponential curve or curve or something like that, which is not linear? In that case, if you see the energy consumed by a server with 40% and energy consumption by a 30% server, if you sum it, it is okay less than okay the 70% server. The 70% server consumes more energy because if the utilization will increase, the power consumption will also increase in a drastical way. In a drastical way. But suddenly it is increasing. In that case, if you see, the second solution is a better one in comparison to the first solution. Okay, second solution is better than better in comparison to the first solution. So it depends. It depends that whether solution one is better or two, based upon what kind of model we are using for energy consumption. Is it clear? Is it clear? Please write in the chat box. Those who are writing solution one and two. Is the concept clear? In which case solution one is better, which case solution two is better? Okay. So you check whether the model is your whatever you are considering, whether the model is a linear one or the model is a non-linear one. Any doubt in this? Any doubt? Please respond. Okay. Next is see here. If you go for virtualization for infrastructure as a service, I told you infrastructure as a service is provided. Very famous cloud service provider for IaaS is your Amazon. Amazon is very famous and gain maximum revenue for providing the infrastructure as a service. So the concept is here. The concept is that system administrators consolidate workload of underutilized server in fewer server. If a server is underutilized, if you see this server, let us assume that there are 4 servers. Out of these 4 servers, let my underutilized threshold is let's say less than 25%. I observe that these 3 servers are utilized less than 25%. So what I will try? I will try to consolidate this workload to a server. Okay, let's say this is the server. I want to migrate or consolidate the workload to this server. Okay, so that the number of servers required to run a particular application will be less, and within a fewer server I can achieve my goal. That's why you have to see which server is underutilized, which server is overutilized. It does not mean that you will go for 100% out, 100 out of 100 utilization. If you continue with the 100 utilization, there may be a chance that the server will be crashed, right? So both factor you have to see. You have to see the underutilization as well as you have to see the overutilization as well. So that is the first part. Second one is virtual machine has the ability to run legacy code without interfering with other APIs. That I repeatedly told you. Every cloud service provider is having different API. Okay. So like that, whenever you go for these virtual machines, also whatever APIs are there, that it may be different. So without interfering this API, if you can migrate this load from one physical machine to another physical machine, then you can save energy. Third factor is if you are using virtualization technology, right, and you are creating the virtual machine is going to provide you a improved security mechanism rather than the traditional system where the security threat is there. But whenever you go for the virtual machine can provide you improved security mechanism because it uses the sandboxes. 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 The main reason is that it is separating one program with another program. Like on top of a single physical machine, suppose I am installing 3 virtual machines. So I have to ensure that these 3 virtual machines are treated as a separate one. These 3 may belong to 3 different users. That's why they should be treated as a separating. They should be separated and they should be treated as a new instance. They should not collide each other, so that the execution of one user will be affected by another user. Okay, and they can provide you a greater reliability. Whatever reliability provided by on-premise traditional IP, if you go for virtual machine technology, virtualization technology, where you are deploying virtual machines, if you see the reliability is drastically improved. Next one is virtualized cloud platforms can apply performance isolation. You can isolate also one virtual machine to another virtual machine, one job with another job. Although it is a challenging, but it is possible by the help of virtualization technology. And you can provide the better quality of service to the customer application. Based upon the customer requirement, you can create the virtual machine and deploy the virtual machine on top of the physical machine, right? And you can achieve whatever the quality of service asked by a particular user, right? See, next another concept, important concept that is called as VM cloning. VM cloning means just we are copying the virtual machine. Why we needed the virtual machine? We need to copy the virtual machine. It may happen that one virtual machine will be crashed. That's why in cloud, each and every term there is a backup system. Like network, we have studied there is a primary system and there is a secondary system. The purpose of the secondary system is that when the primary is failed, okay, then the secondary will come into picture and do the necessary work. Right? There VM cloning will work. So if you see here, suppose one case I want to recover one physical machine by another physical machine. Try to understand these two words. One is we are talking about the physical machine, another we are talking about VM. Let us compare these two and see which one is better, which one is easier and which one is complex. A physical machine is holding multiple virtual machines. Like I told you in our case, let's say Amazon case, we have several EC2 instances on top of the physical machine. One physical machine is having 3 virtual machines. So migrating the load of the entire load of a physical machine to another physical machine. In the first scenario, I am migrating the load of a physical machine to another physical machine in the first scenario. Second scenario, what I am doing? I am migrating the load of a single virtual machine to another physical machine who is going to host that who is going to host that particular virtual machine. First case, I am migrating the entire load. That is nothing but the recover of one physical machine by another physical machine. Second one is the problem. Suppose the problem is there with virtual machine 1. That virtual machine only I am migrating to another physical machine. Which one is easier? Obviously, second one is easier. In the first one, you are doing the entire load. So what happened? It is a slower process, complex process, as well as the expensive process, because the entire load you have to share, or you have to migrate. But in the second case, if you are defining difficulty, the virtual machine needs more resources or something like that. So what you can do? You can do this migration from one physical machine to another physical machine. So such type of migrations are sometimes done at the runtime. That's why we call it a live migration. Okay. You can suspend the virtual machine and take their system image, and the same system image you can resume in another physical machine. So it will start from that point. It will start from that point. It will not start from the beginning. Suppose 50% work is done. From that 50%, it will start in another physical machine. Okay. Virtualization aids in fast disaster recovery by VM encapsulation. So by the virtual machine, you can also do the fast disaster recovery. Okay. And the reason of cloning the virtual machines is that if a virtual machine will be crashed, then the same thing will be required from other virtual machines. That's why in many cases it is suggested that a single copy of the virtual machine should be replicated in at least three places. Okay, whatever data is there in a particular virtual machine, that should be replicated to at least three places. So if it is failed, then I should retrieve or recover the things from another three sources. Obviously, this parameter is decided by the user, but at least the minimum backup you have to maintain. Okay, otherwise, whatever emails you have, if it is maintained in a single one, so sometimes it will, if it will fail, then what will happen? All the emails will go. You will not able to retrieve a single email. So that is the demerit you may get if you go for a single copy of the data. Okay, that's why multiple copies are taken and stored in various physical machines. Okay, but there are six open challenges with respect to the architectural design of this. Either you can say the compute cloud or you can take the storage cloud. There are some challenges. Some challenges are already solved, but few challenges are still there as a open resource problem. First one is availability. Nobody will suggest you, as you know that as a computer science student or computer science engineer, you know that availability is never be 100% or reliability is never be 100%. You cannot say that you will available, your system will be available 100 out of 100. So service availability, like I told you, Amazon is 99.99. Total 11 nines are there. Why they are going for rest 99.99? Why not they are mentioning 100%? Because they assume that there may be a failure. We cannot say that we are available for 100 out of 100 times. That is also required with respect to the security aspects, with respect to the power aspects, with respect to various aspects. With respect to various aspects, we can say that the system will be available or the system will be reliable or not. Okay. Another problem is still going on, that is called as your data lock-in problem. You can also do research in this particular area, data lock-in problem. Okay. First case, service availability depends upon whether the service is available to all the customer throughout a particular year or a particular time duration or not. But if you go for some kind of attack, like I mentioned here, distributed denial of service attack. Distributed denial of services, you can launch this attack from various places. Okay, a malicious computer can inject such attack in a computer network, right? In various places. So what it will do? It will slow down the service. If it will slow down the service, availability is less, right? If some malicious node will consume the entire bandwidth, then what will happen? A genuine user or genuine computer system cannot communicate, right? So in that case, what happened? The service availability will be less. Second one is the data lock-in problem. Data lock-in problem says that whatever things are there with respect to a particular cloud service provider, if you want to move from one cloud service provider to another cloud service provider, then the same thing may not work. That's why it is saying customer are dependent on a single cloud provider. they cannot easily move to other provider due to their data constraint, due to API constraint, their library constraint, due to many constraints. So you are locked in a single cloud service provider. That's why it is called as data locking provider. If you are using Amazon cloud, if there is some offer is given by some other cloud service provider, so if you want to planning to move, it is difficult for you. So it is still a open research problem in cloud computing. Obviously, the privacy and security is also a major concern in any domain, not necessarily in cloud domain. Any domain you are, you do research, always there is a question about the security and privacy of that particular domain, right? So it may happen that whenever a sender want to communicate with a receiver, okay, let a sender want to communicate with a receiver. So what happens? There is a security loophole, right? So what will happen? There is a third party, right? That third party want to interfere with these two sender and receiver and want to get the information from the sender, okay, and want to also receive the information from the receiver and modify such information, okay, and send the information to the receiver as well as the sender. So sender thinks that this message is originated, whatever message it is received, or receiver thinks that whatever message it is received, that is from a genuine user. But practically it not happens. So that is an example of our main intermediate flow. So this person is taking the data of both sender and receiver and manipulating them and behaves as a sender for this receiver and behaves as a receiver for this sender. Okay, such type of attacks will mislead the security and privacy of data. Right. Third one, can we achieve the unpredictable performance, or is there any bottlenecks with respect to a particular? Like I told you in some class also, while we are discussing Gustafson's law and Amdahl's law, I told you increasing the number of physical machine does not give you 100% performance. You have to see whether parallelism is there or not in your program. Another system, whatever program you have written and whatever resources you have, they are properly utilized or not. Otherwise, you cannot say the performance will be increased. So I am going for multiple virtual machines. What will happen? CPU can be said, main memory can be said, but what about IO? IO is there is a question mark. Whether input output can also be said to multiple user, that is a question mark. You can set the CPUs, you can set the memory, you can set the storage, but what about the IO? So that is also one of the button. And also one of the important thing, number of CPUs if you increase or number of resources if you increase, whether you will get the good performance or not, that you cannot say. That is a your open challenge. Next open challenge, the data is not stored in a single place, right? There are a lot of data centers are there, and these data centers are not located in a single place. They are placed all over the world. So there is a distributed storage. Okay. So it may happen that there is a data inconsistency. Like I told you, whatever data you have or your virtual machine has, that data is copied to three different places, right? If it is placed in the three different places, if something is modified or something is resulted in a particular virtual machine, so the resultant or the result need to be propagated to other copies as well, right? Suppose you are storing the same data in multiple places, so you have to ensure that the same data is available in all the places. Otherwise, what will happen? That will lead to data inconsistency. Debugging is also very difficult. Okay, you may find if you are taking a copy of the virtual machine from another zone, then you will see something is not updated. You may not get the latest one. So that is also one of the challenge. And the next challenge is with respect to the cloud scalability, interoperability, and standardization. Till now, standardization is not achieved. Although many European organizations have already tried to make provide standardized services to the customer. Okay, but till Now the standardization is still a question mark. Like somebody used off peak price, on peak price, their pricing mechanism is different, that we discussed already. Somebody may use pay as you go model, okay, and their charge rate is also different. Somebody may charge hour basis, somebody may go for subscription basis. Somebody will see how much bandwidth you are consuming. Somebody will see that how much storage you require, based upon that it is charging. So there are various mechanisms there in which one cloud service provider is different from another cloud service provider. That's why standardization is not achieved in there. So here you can see there is a format that is called as your open virtualization format. So it is a open, secure, portable, efficient and extensible format for packaging and distribution of VMs. So whenever a VM is assigned to a particular physical machine, its characteristics, its features, and its associated data also need to be sent to that physical machine. Otherwise, that physical machine is not good, which we generally refer as system image. That image needs to be transferred. So if that image, whatever you are transferring, right, between two different data center, and these two data center are owned by two different cloud service provider, then also you will face the standardization issues. So in order to avoid that, you have to use open virtualization format that will famous in all this ODA. Another challenge is called your software licensing and reputation sharing, right? Software license is always a problem, right? Because this licensing is a part of your service provider, not a part of service consumer. Because service consumer is using your service, so it is up to you to renew that license. If any software you are providing as a service, like people are thinking, why not the MATLAB software will be provided as a service, right? So this licensing is taken care by your cloud service provider, not by you. And whatever service you are providing, people are also taking feedback, right? Whenever we are purchasing a particular product, what we are doing, we are asking our friends whether that product is good or not. So the reputation also plays an important role. Like I told you, people are relying on Amazon, okay, rather than they are relying on other cloud service provider. Okay, before start the next one, the public cloud platform, let us take a poll today. So I am sharing one question. Please try to answer within 1 minute. What is the correct answer? What is the correct answer? AWS is provided by whom? Amazon. Okay. So next topic just to discuss about the public cloud platform. As I already told you that Google App Engine, Amazon Web Service, and Microsoft Azure. These are the three public platforms. You create your account and give your basic details and try to explore these three public cloud platform so that you will get the details about this particular platform. Okay, but if you go for these public cloud platform, there are 5 levels of cloud players. Okay, the first layer is our user. So user may be there in the top layer, or broker may be there in the top layer. On behalf of a particular organization, there is an admin, right? That admin is using the cloud services. That is the first layer. Second, third, fourth is known to you. One is called as software as a service, platform as a service, infrastructure as a service. And the last player is also belongs to your IAS. That is nothing but a hardware provider or maybe software provider. So you may rely on hardware or you may rely on the software that is also provided by some person. Like infrastructure is provided by some provider, platform is provided by some provider, application is provided by some provider. So with respect to each level, you have different players. It may happen that what like Amazon case I told you, Amazon is relying providing infrastructure as a service. You go for Google App Engine. Google App Engine is providing platform as a service. Go for Microsoft Azure. Microsoft is Azure is providing IaaS, PaaS as well as SaaS. So one cloud service provider may provide all types of service, or they may provide only one type of service. Okay, so these are the basic levels where various players are acting in order to fulfill the job of in order to fulfill the requirement of the customer. So this is a clear-cut example in which the 5 providers are there. Apart from this, Amazon, Google, and Microsoft, is also there, and Salesforce.com is there. You can compare these 5 cloud service provider in terms of platform, infrastructure, software as a service, the 3 popular services. Also, you can compare with respect to virtualization, what kind of service they are offering, what kind of security features they have, user interfaces, and web API programming software. So you can compare. So if you get a comparison chart, you will clear that if a particular customer requirement is infrastructure, which cloud service provider is suitable for that customer. For example, you can see here, suppose I need infrastructure as a service, then I can go for IBM, I can go for Amazon, Google is not providing that, Microsoft today, Salesforce is not providing that. So it is a given in the this chart is given in the book, but if you go for today's cloud service provider, they are more or less providing all types of services. So you can compare what kind of virtualization techniques they are using, whether they are using KVM or they are using VMware or they are using operating system kernel, right? OS level or the container. Okay. So these things are you can compare with respect to one cloud service provider to another cloud service provider. If you go to Google, Google has a lot of data center. You can say hundreds of data centers are there, in which you can say 460,000 servers or more servers are there. And one data also told that 200 Google data centers are used at one time. Just this data convince you that how many users, why they switch on these many data centers, because they want to execute the user applications. So with this large data, we have to assume that how many customers they have, nothing else. So GAE was developed in the year of 2008, and it is very famous for the platform as a service. And you know that platform as a service is providing runtime environment, and it is backed by your infrastructure as a service. So if you want to deploy any web applications where scalability is required, you want to extend, you can expand the services. So expand the number of requirements, then you can go for GAE subscription. And GAE, if you go for GAE uses a lot of component, like you heard about the Hadoop or Hadoop distributed file system, which is famously called as SDFS, or you have heard about the Google file system. So this GFS component, okay, GFS is providing you a feature that large amount of data you can store in Google App Engine. And if your application consists of large amount of data, that can be stored using GAE. Okay, it is also providing you the MapReduce programming framework in which you can develop your application. Similarly, in order to go for distributed application log service, they have another one Chabu. In order to store the data and retrieve their access is a structured data. Like you know that in big data, structured data is in more compact form in comparison to semi-structured or unstructured data. Doing a meaningful calculation in the structured data is more easier. So such data can be stored in the big table. So you can see this is the complete picture of Google Cloud Platform, and there are major building blocks where the Chubby is there, as well as the big table is there, MapReduce is there, Google file system is there. In each and every node, it is maintained like this. Like you can see, this node is having the Linux operating system. Okay, on top of the Linux system, you have a scheduler and Google file system to store the large amount of data. These data can be processed using the MapReduce. Okay, you have to make key value pair, and there is a data node, and there is a data node can transfer the data to number of worker node in order to get the job done. And structured data is stored in this big data table. Okay, so this complete one is your infrastructure of your Google App Engine, or the components of the Google App Engine, which is given to the user. The user can interact with this Google App Engine even user interface, right? So this is the complete picture of our Google App Engine. Similarly, if you see the building blocks, right, or the modules used in the Google App Engine, whatever we discussed, first one is called as data store. Generally, nowadays, the data is stored in the object-oriented format. If you go for Amazon also, Amazon uses S3, simple storage service, where data is stored in the form of object. And data is stored in a distributed manner, not in the centralized manner. So, this data store unit store the data of GAE in a object-oriented. The data is treated each and every component, whether you store a text file, go for an image file, everything is treated as an object and they are stored in a distributed fashion. Structured data storage is stored in the form of big table. Big table coordinates that particular thing. Another functional module of Google App Engine is called as your application runtime environment. So you can use any application. You have to see what kind of programming environment is supported by your cloud service provider. For example, Google App Engine supports your Java programming language as well as the Python programming language. These two you can use. And in order to develop the local applications, I told you, you have to build the application, you have to upgrade the application, you have to launch the new version of that application. Your software development toolkit will help you. That is SDK. There is also a functional module in order to monitor everything. We have an administrative console so that easily we can manage. You can also keep track of the user application. The last functional module is your GAE web service infrastructure, which is providing the flexibility. Okay, so it is providing the flexible use of the GAE to the user and manage the software or hardware components of the Google App Engine. So these are the 5 functional modules. Like you know that we are using Gmail, and Gmail is provided is the 15 GB of data, right? Up to 15 GB of data, the service is free. That's why he is saying if you have a Gmail account, you can use the GAE service subjected to some free quota. Like I told you in Amazon EC2, 750 hours is free. And 750 hours is free up to in each and every month you can use 750 hours up to 12 months. So once the quota is filled, once you are completed with these 12 months of subscription, if it is so, then you have to pay for the services. Beyond the quota, you have to pay. Like Gmail, once you exceed the 15 GB, if you still want to store your data in Google Drive or in your email box, then you have to pay for your service. Otherwise, you will not able to receive email. So in order to subscribe such thing, what you have to do? You have to subscribe this software development kit, right? SDK, and read the terms and condition. Python or Java guide is there to start, and you can deploy your user built application on top of the cloud infrastructure once you are exceeding the quota. And GAE also provides various type of applications which we are using in day-to-day life. Like Google Search Engine is there, Google Docs is there, Google Apps is there, Gmail is there. And web application built on top of GAE can use the APIs authenticating users, and you can also able to send emails using your Gmail account or your Google account. You can use email to send the emails, right? Okay, we'll stop here for today.